let's get into it. How do I factor x squared minus x minus 12? Well, I'm looking for a pair of numbers that multiply to give me negative 12 and add to give me negative 1. That's going to be, we're going to use 3 and 4. That'll be positive 3 and negative 4. So my outer, I'm going to make positive 3x. My inner, when I FOIL, will be negative 4x right there. So that's my factored form. Now, absolutely do not, if you know what's good for you, do not be that person that is about to write that this inequality is less than 0 and this thing's less than 0. If you do that, you are going to be forever exiled to math jail, because that is not a thing. No one is ever going to show you to do that. Don't do that. What don't you do? You do not take each one of these and say that they are less than 0. Not a thing. Your teacher's not showing you that. No, no, no. I just solve when they're equal to 0, because that is giving me my x-intercepts. So if I solve those right there, my x-intercepts end up being, I have one at x equals positive 4 and one when x equals negative 3. Those are the x-intercepts of the parabola. Do you need to draw an entire graph? No, I'm just being extra because that's what we do here. An intercept at positive 4 and negative 3. So it's positive x squared, so that means that the ends are pointing up, like this and like this. Now the factors that these came from were both to the first power. That means my local behavior, not my end behavior, but my local behavior is linear for both of them. That means if I were to zoom in and only look at that x-intercept, my graph would slice through like a straight line. So I wouldn't necessarily know that I was looking at a parabola if I was really, really zoomed in. Same idea over here. It's going to look like it slices straight through. Then obviously it's a parabola though. We know that this whole thing is going to curve around and connect. It's a polynomial. It's smooth and continuous. The domain is negative infinity to infinity. So here's my sketch of Rooney. Now, what about the 0? Glad you asked. Y equals 0. Where does y equal 0? Everywhere on the x-axis. Y equals 0 is the x-axis. Say it with me again. Y equals 0 is the x-axis. It is not the y-axis. Okay? X equals 0 is the y-axis. Think about it. I promise I'm not lying to you. When is the red graph below the blue? Here's the blue. When is the red below the blue? When is the red below the blue? Here, in this region in between. And how do I describe that region in between? Using interval notation. Basically, I'm going to say from negative 3 until positive 4. We're using parentheses because it's not including those values. It's right up until those values. If the question, on the other hand, had asked when is this greater than 0 or greater than or equal to 0, in that case, we would be describing these pieces. My answer would look something more like negative infinity until negative 3, union 4 until positive infinity, because it's asking about this. When is the pink graph or red graph above the blue graph? This will work for any polynomial inequality. So you can do this even if you have, say, a cubing function. We just find our x-intercepts, figure out when it's above or below. You don't even have to test intervals if you understand how to graph a polynomial using my method. So check the playlist on how to